That wall of scary red text when a program dies is not a mystery. It is an exception. Python's way of saying it hit something unexpected. Every crash you have seen, from indexing too far into a list to adding a string and a number, was an exception being raised. Until now, an exception has always meant the same thing. The program stops and the only response is to go back and debug. Python offers another option. With two keywords, try and except, you can catch an error the moment it happens, respond to it, and keep the program running. We will build the same function twice. First without exception handling, then with it, and watch a crash turn into a graceful recovery. Most of the time, code runs from top to bottom and produces the output you expect. Sometimes execution reaches a condition the code cannot handle, an unexpected situation. At that moment, Python raises an exception, a signal that something other than the expected thing happened. Unless the code does something about that signal, the consequence is fixed. Python halts the program on the spot, prints the red error report, and never reaches another line. The central idea of this video is that raising an exception and ending the program are two separate events, and the second one is optional. Several kinds of exceptions have already come up. Ask a list for an element it does not have. Say, asking a 3-element list for the element at index 5. And Python raises an index error, list index out of range. Combine types in a way Python refuses, like adding a string and an integer, and it raises a type error, complaining that it can only concatenate a string, not an integer, to a string. Break the grammar of the language itself, and the syntax error appears before the program even starts running. Use a name that was never defined, and the NameError reports that the name is not defined. 4 different names, one family. Each of these is a type of exception, raised the moment its unexpected condition appears. Until now, the story ended at a crash. It does not have to. Python lets us write code that handles an exception when it occurs. A handler can ignore the fact that an error occurred, substitute a sensible default value, or raise its own, more informative exception and move on. The construct is a pair of keywords, try and except. The potentially problematic lines, the ones that might raise, go inside the try block. Try is a reserved keyword. Naming a variable try is illegal, and an editor colors it like any other keyword. The lines inside are ordinary code. The except block underneath holds the response. What to do if those lines fail? Here is exactly how the flow works. Python starts executing the lines inside the try block in order like normal code. Case 1. Every line succeeds and no exception is raised. Then the except block is skipped entirely. Not one line of it runs. And execution continues after the whole construct. Case 2. One of those lines raises. The program would have crashed right there, but instead, Python abandons the rest of the try block. Any lines after the failing one never run, and hops straight into the except block, whose lines now execute. Either way, the program survives and carries on. The except block is a landing pad, used only when something goes wrong. To connect this to control flow, we already know. Imagine a strange if statement. Its condition asks whether all of the potentially problematic lines run successfully. If they do, the body is essentially a pass. Nothing extra happens, the else never executes, and we carry on with the rest of the program. If one of those lines would crash, Python declines to crash just yet, and hops inside the else to deal with the problem. The try block plays the role of that condition. Run these lines. The except block plays the role of that else. Here is what to do if they would have crashed. Nobody writes an if like this. It is only a bridge from a familiar construct to a new one. Time to use this on a real function. Some digits takes a string s, assumed non-empty and containing digits, and returns the sum of the characters that are digits. The specification says nothing about non-digit characters, so we write it defensively. A running total starts at 0. A for loop walks the string one character at a time. For each character, an if statement checks membership. If the character is in the string 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it must be a digit. In that case, we convert it to an integer and add it to the running total. When the loop finishes, we return the total. Call some digits on the string 1, 2, 3. 1 plus 2 plus 3 gives 6, and the function returns 6. Now feed it messier input, the string 1, 2, 3, ABC, digits followed by letters that cannot be added. The function still works. The first 3 characters pass the membership test, so the total climbs to 6. When the loop reaches the letter A, the if test fails. That character is not in the digit string, so the body is skipped and nothing gets converted. Same for the letter B, and same for the letter C. The loop walks past every non-digit, and the function returns 6 with no complaints. The guard makes the code robust. Characters that will cause trouble never reach the conversion. Watch what happens without that guard. Delete the if and convert every single character that comes along, adding each result to the total. On the string 1, 2, 3, this version still works and still returns 6. Every character is a digit. On the string 1, 2, 3, ABC, it crashes. The moment the conversion meets the letter A, Python raises an exception. ValueError, invalid literal for int with base 10, then the letter A in quotes. That red text is dense, but the diagnosis is in there. We asked int to turn the letter A into an integer, and no integer matches. The potentially problematic operation is exactly one line, the cast to an integer. That is the line that belongs inside a try. Here is the same function with exception handling. Most of the code is unchanged. The running total, the loop, the return. The middle is different. No if guard at all. We assume every character converts and we try it. Inside the try block sits one statement. Convert the character and add it to the total. The except block underneath prints the words can't convert, followed by the character that failed. Trace the string 1, 2, 3, ABC. The first 3 passes through the loop convert cleanly. The try succeeds. The except is skipped, and the total reaches 6. On the 4th pass, the conversion raises a value error. The program does not crash. Python jumps into the except block, which prints can convert, then the letter A. That iteration ends, and the loop moves on. The letter B fails the same way, and then the letter C. 3 printed lines appear, and the function still returns 6. The crash became a report. Step back and collect the idea. An exception, IndexError, TypeError, SyntaxError, NameError, ValueError is a signal that something unexpected happened, not a verdict that the program must die. Lines that might fail go inside the try block. When they succeed, the except block is skipped and costs nothing. When one raises, Python abandons the rest of the try and lands in the except, which decides what happens next. Ignore the error, substitute a default, print a report, or raise a clear exception of your own. The same input that once killed the program now produces 3 polite messages and the correct answer. That is the difference between crashing and handling. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.